Hello and welcome to Nikolai's genetics lessons, and today's problem is disease X is a blood disorder caused by mutation in a clotting factor gene. Jane's father, sister and brother have disease X, but her mother doesn't. Jane's male cousin also suffers from disease X, even though his parents are healthy. Her uncle has the disease, but has a healthy son. Find the mode of inheritance. So take a look. Here is Jane and her father, sister and brothers has this disease. This genetic disorder cannot be dominant because in this generation we see that one person is affected. In this generation we see two people who are affected, but here none of the parents are affected and the son is affected with this genetic disorder, and dominant genetic disorders cannot skip generations. So it can be whether X-linked genetic disorder or autosomal recessive genetic disorder. And for example, we can explain it that parents here would be of the genotype capital A small a, capital A small a, and the son would be homozygous recessive. And of course, in this case, mother is going to be homozygous recessive and father have to be heterozygous, and this person would inherit two recessive alleles here. And in this case we have to suggest that female here is heterozygous, and this is how these children would be affected because they inherit recessive alleles from both of the parents. But there is also another explanation. Take a look. Let's assume that this is X-linked recessive genetic disorder. So phenotype of this female is known, and genotype have to be two defective X chromosomes. And father may have normal X and normal Y chromosome here. And this male is going to inherit normal Y chromosome from his father, so normal Y chromosome, and defective X chromosome from his mother. So for his mother, in order to be affected, she have to have two defective X chromosomes. But for male, because he is hemizygous, has only one X chromosome, even recessive genetic disorder would be expressed as dominant genetic disorder because there is no another X chromosome. And in this case we have to suggest that his wife have to be heterozygous, so her phenotype would be normal, but one of the chromosomes have to be defective. And in this case, for example, we see that this male is affected with this genetic disorder, so he got from his mother defective X chromosome, and from his father normal Y chromosome. And this female here got defective X chromosome from the mother side and from the father side. So her genotype would be X, X2, defective X chromosomes. And this male here got X chromosome from his mother side, and of course from his father side he got normal Y chromosome, but again, because males are hemizygous, he would be affected with this genetic disorder. And of course it is easy to say that this male got defective X chromosome from his mother side and normal Y chromosome from his father side. So in this couple, all progeny, male progeny, have to be affected with this genetic disorder. But we see that this female is unaffected, but her son is affected. That means that she got defective X chromosome from her mother side. There is no any other variants. Both X chromosomes are defective, but from her father side she got normal X chromosome, and here is her genotype. And now take a look. This male, he from his father side he only can get Y chromosome as X chromosome, and from his mother side he can get whether defective X chromosome or normal X chromosome. And he got defective X chromosome. So it seems like this genetic disorder skipped one generation and reappear in next generation. And some of you may say that this is autosomal recessive genetic disorder, but it also can be X-linked recessive genetic disorder. In this case, we just have to assume that this person here is heterozygous who is unrelated to this family. And in this first explanation, we have to assume that this unrelated to this family person, genetically unrelated, is heterozygous for this genetic disorder. So as you see, both these explanations can explain why this pattern of inheritance happened here, and probability would be the same. Here we assume that this person is heterozygous, and here we assume that this person is heterozygous. Now let's assign genotypes for other people in these pedigrees. For example, what is the genotype of the Jane? She got normal X chromosome from her mother's side, and she only can get defective X chromosome from her father's side. So her genotype have to be heterozygous, but phenotype is going to be normal, because this is recessive genetic disorder, X-linked genetic disorder, and one normal X chromosome is enough for normal phenotype. And for example, what we see here, we assume that this female who is unrelated to this family would be normal for both X chromosomes, and genotype of this female here have to be heterozygous, so she can inherit from the father side only defective X chromosome, but from her mother side only normal X chromosome. And as for this male, from the father side he inherited Y chromosome, and from the mother side he can get only normal X chromosome. And as for these people here, genotype of this male is going to be normal X chromosome from the mother side, Y chromosome from the father side, and normal X chromosome from the father side, and the other chromosome can be with defective or normal, it doesn't matter, phenotype is still going to be normal. And we left only one person here. So from mother side, she only can inherit defective X chromosome, but from the father side, only can inherit normal X chromosome. Now let's finish this pedigree. So if these two parents are heterozygous and phenotypes of these two people phenotypically normal, again, this can be just one dominant allele inherited from any of the parents would be enough in order to show dominant phenotype. Again, here we assume that this unrelated to this family person is homozygous normal. Children are going to be heterozygous and going to be phenotypically normal. And as for this female here, she inherited one dominant allele from father side, and from the mother side only can inherit recessive allele, but phenotype is still going to be normal. And as for the Jane, again, she inherited from her mother side dominant allele, and from her father side she only can inherit recessive allele, so she is going to be a carrier, going to be heterozygous, but phenotype is going to be normal. So after all, which mode of inheritance is most probable? Take a look at the first pedigree. In order to see this pattern, we have to suggest that this unrelated to a family person have to be heterozygous, and also this unrelated to the family person have to be heterozygous. And in second suggestion of the mode of inheritance, we just have to suggest that only this person also have to be a carrier of this rare genetic disorder. So we can explain this rare genetic disorder with least number of suggestions. So probably this would be the best variant to choose, those this variant also can happen. So we also can explain what we see if we assume that these two people unrelated to this family would be carriers of this genetic disorder. And this is all for today. Thank you for your attention. Please subscribe for my new videos that I post almost every day. And see you in the next video. Goodbye.